Hello again. Okay, in the next video, what we're going to be going through is real GDP per worker. So we had the production function, which is how real GDP is determined. And next we want to look at real GDP per worker. So we'll divide both sides by L and see what we can get. Real GDP per worker is really productivity. And we'll see what productivity then depends on. One of the things it depends on is the amount of capital per worker. When each worker has more capital to use, they can be more productive. And the more capital they have is called capital deepening. The less capital we have per worker is called capital dilution. So we'll go through both of those in terms of the production function, the new production function that we'll develop based on real output per worker. Then we'll go through a little bit with growth and productivity, because in order to grow, productivity has to increase. So the growth rate of productivity is highly related to the growth rate of GDP in the economy. And then we'll go through and look at how is productivity increased then by looking at the production function. Okay, first, let's look at the real GDP per worker. Now remember, the production function we're using here is Cobb-Douglas, and output is equal to A, total factor of productivity, times capital to the alpha power, times labor to the beta power. And remember, both alpha and beta are greater than 0 and less than 1, and alpha plus beta together equals 1, and that gives us constant returns to scale. What we want to look at now is real output per worker. So Y over L. And that is going to be equal to everything on the right here divided by L. Now, a couple new variables I want to give you that's consistent with the books. Real output in the economy, for the entire economy, divided by all the workers, is real output per worker, which we write as little y. And along the same lines, the total amount of capital in the economy divided by all the workers in the economy is the amount of capital per worker, which we write as little k. Unfortunately, little k and big K look a lot alike, so I'm going to try to just extend the top of the K as much as I can to let you know that that is little k. So little y is output, real output per worker. And little k is the amount of capital per worker, which is the capital to labor ratio. So capital to labor ratio, the amount of capital on average that each worker has. So now we can write this equation here, the big Y over big L, as little y. And that's equal to A times K to the alpha times L to the beta minus 1. And remember that alpha plus beta is equal to 1. Therefore, beta equals 1 minus alpha. So we can write this as L to the 1 minus alpha minus 1. So now this will be little y equals a times k to the alpha times L to the minus alpha, or divided by L to the alpha, which means that y is equal to a times big K over big L to the alpha, which is little y equals a times little k to the alpha power. And since alpha is less than 1, that means that little k, the capital to labor ratio, shows diminishing returns, which makes sense. The more capital you add to the society, the economy, keeping the number of people constant means that they can be more productive and produce more, but there's diminishing returns to it. So if we draw this, draw it over here, and we put little y on the y-axis and little k over here, we would write this as, draw this something like this, something to show there's diminishing returns, and this would be holding a constant. We know it's got diminishing returns because that alpha is less than 1, and we can show that by showing that the slope of that curve is greater than 0, but it's decreasing. So the first derivative, little y with respect to little k, is going to be alpha times a times k to the alpha minus 1, which is greater than 0. And the second derivative of little y with respect to little k is going to be alpha minus 1 times alpha times a k to the alpha minus 2. And that's going to be less than 0 because alpha minus 1 is less than 0. This little y, y over L, is productivity. So on this axis, we'll just write here little y, or productivity. Because productivity is output per worker, usually measured by how much a worker can produce in 1 hour. So as we have more capital per worker, the productivity rises of each worker. Now, having more capital per worker is called capital deepening. So here, capital deepening is increasing the capital labor ratio. Which is little k. Capital dilution is just the opposite, is decreasing that capital to labor ratio. Now, the reason why some countries have more income than others is that their workers are more productive. If the workers in one country are more productive than the workers in another country, they're going to be able to produce more in the same amount of time, and they will have more. Their output per worker is going to be higher. Their standard of living is going to be higher. Now, there's a couple of different ways that countries can be more productive. Remember, little y, which is productivity, is equal to A times little k to the alpha power. Little k is the capital labor ratio. So either they increase the capital labor ratio to be more productive, or they increase A. In our model here, that's the only way it can be done. Either more capital per worker, or A, total factor productivity increases. If either one of those increases, then productivity of the workers increases. They'll be able to produce more, and the standard of living will rise. So remember, real GDP per capita, which per person in the country, defines their standard of living. We can write that as Y per capita. That's our symbol for real GDP. That will increase as long as productivity increases, because productivity is closely related. That's output per worker. The difference is not everybody in the economy is working. Output per worker we can write as Y over L, which is essentially output per labor hours, and usually measured in increments of 1 hour. How much can a worker produce in 1 hour? And that way we can make comparisons over time and comparisons between countries. If we use something like a month or a year, it's not going to work, because in the developed countries, people tend to work longer hours. More days per week, longer days, maybe 60 hours a week instead of 40 hours a week in this country. So any increase in productivity is what drives growth. So increases in productivity is what determines growth. We want to grow in the country, we got to increase worker productivity. And the faster we increase worker productivity, the faster that we can grow. So once again, remember that little y, which is real output per worker, is worker productivity. In our Cobb-Douglas production function here, we end up with this worker productivity is equal to A times little k to the alpha. And we put little k down here, we get our productivity curve that shows diminishing returns. So we want to increase worker productivity. Once again, we got to increase the capital labor ratio, or we increase A. Because as A increases, the total factor productivity, this will move the curve up. So A increases, that moves the curve up. So this curve, the blue one, will be something like, we'll call it A1. And the next curve up would be a higher level A. We'll call it A2. Now that you might think from this, well, then the difference between real GDP per worker in some countries is higher because is only because they have more capital per worker. Not true. Turns out that capital increases, the difference between capital and countries does explain some of the reasons why some countries are richer than others. But it doesn't explain everything. This, by the way, is called the solo residual. There's something else that explains why some countries are richer than others, other than just physical capital. Now, if we were to add human capital to the production function, we would find that that helps explain some of the difference between wealth and countries also. So some of this difference between the incomes, why some countries are richer than others, is accounted for by physical capital. Some of it's accounted for by human capital, but there's something else in there also. And that something else is in this A category, this total factor productivity. Because remember, that's kind of a catch-all. It's technology, but it's a catch-all for everything else that affects productivity for a country or an economy, other than just what's in the production function. So this will include the things like, well, are there property rights? What are the property rights in the country? How much corruption is there in the country? How much economic freedom is there in the country? How stable is the government? Are there a possibility of coups and revolutions? How are they able to absorb the technology in their country? Do they trade? Are they open with the rest of the world, or do they have a lot of tariffs? All these other things that are highly correlated with real GDP in a country are stuck into this A category. Okay, so what we went over in this video is how we take that Cobb-Douglas production function and we turn it into output per worker, little y, which is productivity. And we've shown how capital deepening and capital dilution can affect that productivity. But there's other things too, besides just capital deepening and capital dilution, that affect workers' productivity. Then we went over the relationship between growth and productivity. They're very closely related. But in order for a country to become wealthier, the workers have to become more productive. And the only way a country is going to grow is because they've got to have, it's with an increase in productivity. So we want that growth rate of the country to grow. We've got to increase the growth rate of productivity in the country. And then we went through and kind of looked at how can you increase the productivity in a country by looking at the production function.